Alright. Now we're good. So let's start with what we know. F of x is concave up if f double primed of x is positive. Right? So with your arms, what does that look like? What does concave up look like? Alright? Right? Goal! There we go. F of x is concave down if f double primed of x is negative. With your arms, concave down. Alright. There we go. And then point of inflection is usually the part that people end up getting incorrect. You know the definition, but then you just don't apply all of it. So point of inflection occurs when f double prime, of x is equal to 0 or undefined. But remember, the undefined, the point has to be continuous at that point. Okay? Discontinuities can't be a point of inflection. Discontinuities can't be a max or min. And f double prime of x, sign changes. So on your test, I kept making sure that you only got your credit when you showed both things occurred. Okay? You had to show both because most of the time we forget about this piece of it. Alright? So let's do a quick example of a problem that would be using that definition real quickly. I've done this for you before. F double prime of x is equal to x minus 2 to the 4th, x plus 3 to the 3rd, x minus 5 to the 2nd power. Okay? So, and then I ask you, how many points of inflection are there? So what I'm going to ask you guys to do is right in front of you, you put a thumbs up in front of you so no one else can see and cheat with your answer when I say how many. So I'm going to count from 0. And when you think your answer comes, just put your thumb up right in front of you so no one else can see it. Okay? So, how many of you think there's 0 points of inflection in that one? Alright? So, thumb up or thumb down. I'm not even giving you a chance to write anything down. I want instantly. What do you think? 0 points of inflection right in front of you. Okay? 1 point of inflection right in front of you. Okay? 2 points of inflection right in front of you. 3 points of inflection right in front of you. So I'm just letting you know that many of you did not vote. Does everyone understand what I mean by voting? So the vote means you take your thumb and you put it up here, and when it's not the answer, you take it down. Are we clear? Trying it one more time. If you need to think that hard, you're going to have to make a guess. Okay? Educated guess. All right, 0. Okay? 1. Okay? 2. Okay? 3. All right. I would hope that those are the only answers you have. Others? I would hope not. Okay. All right. So notice I didn't give you enough time really to do any work. I didn't give you time to write anything down. I didn't want to give you that time because you don't need it for this question. Okay? So how do you find your points of inflection? You use your definition. So the first thing you would have done is set that equal to 0 and undefined. Undefined won't matter because it can't be. And you'd find 3 zeros, right? That's probably what you were thinking of. And then you started thinking, oh my gosh, she wants me to do a sign chart in like 2 seconds. That's going to be impossible. And your mind's going through and you're like, oh, right, I'm just going to guess a number. So would I rush you and make you skip something that important? No. There must be a reason why I forced you to come to an answer. Because it's possible to do it without. So this is a problem where you don't need a sign chart. It's because you have polynomial with powers. You done? That's okay. I got it. Alright, so someone raise your hand and explain to me why these would be so important for a sign chart. Okay? Ramsey, I'll take you. Okay, so Ramsey's saying with an even power, we can't get negatives in those parentheses. Okay. Someone extend that? Make it make a little more sense for us? Noah, what do you think? True. Okay, so he says even powers always give us positive. Odd powers can give us positive or negative. All true statements. I haven't heard it yet. So far we got two good things. Can someone connect the dots and make a full statement that would make us be able to answer this question so quickly? Something I've said multiple times in the class. Anthony? You only need to look at the odd-powered factors because, finish the statement, are always going to be positive, therefore. You're just running in circles, but everything you said was perfectly true and beautiful. There's one little statement I'm just missing that kind of connects it for the people that are like, I don't know. What are we looking for? A sign change. Someone make the statement that clearly, explicitly would tell someone how to do the problem without having to do the sign chart. So you take those three answers, put it together, you have a full answer. But it's still kind of unclear. Still, there might be someone in here that's like, okay, so you're doing a sign chart, Ramsey. I don't want to hear the sign chart. Come on, put it together. I have said the same thing every single time, and I'm going to start the statement. Even powered factors. That is true. I'm not looking for always positive. My definition doesn't have positive or negative in there. Nathan, repeat what you said. I don't want to say concavity because we might be talking about max and mins. I might be first derivative. Thank you. Change sign. Laura, don't me. No, we said even powered terms will not change sign because of what everyone just told me. Because they're always positive. So when you take a positive, multiply it by anything, will it force it to change a sign? No. You multiply a positive by a negative number, it's staying negative. You multiply a positive number by a positive number, it's staying positive. There's no possibility that an even power term will change sign at that value because you had no effect on the number. So I'm going to say it again, and you're going to write it down and make sure you don't forget it because I say it every single time we do a sign chart. I have said the exact statement of even powered terms do not change sign. They can't. Okay? All right. So, as a result, that one can't be a point of inflection, and that one can't be a point of inflection. The answer was 1, which I believe only 2 people in the room got. All right? So, basic definitions. This is a problem that comes up a lot that's really quick and easy, but people waste their time making that sign chart. You don't need to make the sign chart for it. If you made a sign chart, there's also an easy way to make the sign chart. You don't care about the even ones and you only do the sign chart with this. Does it now make more sense why? There's 100% not going to be a sign change for those. We don't even count them when we do our sign charts. Remember, we say if it's always going to be positive, we don't even look at those. Square root functions, we know they're always going to be positive. We don't use that part in the sign chart. It saves a little bit of time. And there's always the reason of why we save the time. All right, this guy. Let me see my time. 5 minutes? I don't see the time up here is why. Someone tell me how much time I have left? 5? Okay. So, I'm going to have you use your arms. Concave up. Concave down. Point of inflection is flat across, okay? All right, so I am going to start over here. Arms. Concave up. Remember, you guys said this is concave up. That's how we know. So if it's holding water, concave down, and then point of inflection, I should see your arms go like this. All right, here we go. Don't look at other people. Just look at the graph. I know once you mess up, you try to catch back up. It's a little difficult. I know. Everyone at the end is like, oh, man. Good job. You guys actually did okay. So let's highlight. Okay, I'm going to physically highlight the places, and then we'll kind of define the point of inflection one more time. So I'm going to highlight in that green, pretty dark, concave up. Okay, so that would be all the places that look like this part of my arm or this part of my arm or both. Okay, this is still considered concave up, just one arm up. Okay, all right, so this is concave up. This is concave up. This is concave up. And so is this. And so is this. And then I'll use blue to show you my concave downs. Do you see exactly where your points of inflection had to be? Exactly where it goes from green to blue or blue to green. Therefore, some of you got confused there. That was supposed to be a cusp. There's no point of inflection there because it went green to green. That help you a little bit? Okay? I'm going to do real quickly one more then. A little bit harder. Maybe easier, I don't know. Now, it's F prime. So I'm going to give you a minute to think about how you want your arms and what your arms are going to do to make this happen. Okay? JP's like, why? Why? All right? So make the connection right now on your own. Don't say it out loud. Make the connection on your own. It's okay to be wrong. You're not getting a grade. All right, here we go. All right. It's okay if you don't know. You just kind of hide your arms for a little bit. Lottie, you got it. So get your arms up. You got it. I heard you. All right. Same thing, concave up. So concave up, what did you guys figure out that Lottie yelled out? You're only supposed to look at slope. So my slope is up here. My slope is up here. Yeah. Okay. My slope is up here. And then my slope is up here. All right. In blue, slope went down. Slope went down. Slope went down. Slope went down. And then what about my points of inflection now? Is that a point of inflection? No, because it went actually from, well, are we sure? So if we had a sign chart? Good job. It's positive, positive on a sign chart. You can see it in the green. So actually we only have one there. Suddenly this became one, and this became one. Am I missing one? I am missing one. Beautiful. Any more? Yeah. Ah, there's one. Any others? We're good? Okay. I personally would obviously want you to do the sign chart. And when we do our sign chart for F double prime, what should we look at? Because it's one derivative. Slope. Good. All right. Last thing. I'm going to skip one page because we don't necessarily need to do that. Second derivative test. So, if f prime of x is equal to 0 and, not or, and f double prime of x is positive. So I'm going to draw you concave up, and I'm also going to draw where my derivative is 0. What's happening at my purple point? You would describe it as a minimum, right? If f prime of x equals 0 and f double prime of x is less than 0, concave down, what do I notice at my red point? It's a max. You will 100% be specifically tested on this, meaning you won't be able to make a first derivative sign chart. My example would be, they may give you something like this. F of x is equal to g of x times e to the 3x. You can find the first derivative, you can find the second derivative, but you don't know what g of x is. So they're going to give you a little bit of extra information about g of x, just enough to be able to figure out your second derivative positive or negative, but not enough to make a sign chart for the first. That's how they force you to do it. Other thing to remember, does not, or sorry, let's say fails. Fails for f prime of x equal to undefined, or f double prime of x equaling 0 or undefined. Okay? So don't think that this works if your first derivative gives you undefined and you happen to have, say, like a cusp or a corner. Okay? It won't work. Alright, I am going to show you, I think you guys I already showed. It was the other class I did not show this, and I don't know if I'll have enough time to finish it, but did I show you the concave up, concave down, increasing, decreasing circle? It's a way to kind of relate. Did I? I'll do it real quickly. Real quickly, that, concave down, right? We agree? Concave down. These are concave up on the bottom. And then this piece here is increasing. This piece here is decreasing. This piece here is decreasing. This piece here is increasing. These are all the combinations you could possibly have for a graph. So how would I use that? Say your sign chart, they give it to you and they say, oh, from 0 to 2, draw me something that's concave down and decreasing. So I just copy that piece of the graph. And then they say, oh, the next part of the interval, well, it's concave up and increasing. So then I just draw this piece. So you get to connect the 4 pieces of the circle easily to make a full graph. Okay? That's it. You guys know what your homework is? Yes. It is on the front of the packet. Yeah, I've been